Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode 51. In today's lesson, we're going to be looking at LINQ, sometimes called LINQ. I'll probably be saying LINQ because that's what I learned it as, but it's an acronym. It stands for Language Integrated Query. And it's a way to work with data. Let's begin with an example. So I guess here, I've got a class here I've already created. So we have a person class and it has a name, as an age, and then a toString. We'll ignore the warning. Shouldn't ignore it, but we'll ignore it for this lesson. So one thing we've added using.system.link. So so this is the second time. So for full disclosure, this is the second recording of this video. First one didn't work out, so this is the redo. So we'll go ahead and get started, and we'll see where this takes us. So let's begin with an example. So let's have a list of int numbers equals that. And we'll change to the new syntax. Alright. So let's say we want to get the even numbers in this list. We'll do list of int evens equals this. And now for each bar number mod 2 equals 0. So that's a even. So we're saying for each number, if the number mod 2, so mod just does the division, and then we say is the remainder 0, and if it is, it's even. Here if we do cw string.join evens, we will see we get the expected outcome. If I can get enough parentheses. And we get the expected number, 2, 4, 6, 8, 10. That's called declarative or imperative programming. So we're telling the computer exactly what to do. LINQ gives us a way to do that through another paradigm called declarative programming. We tell it what we want rather than what to do. And that's where LINQ comes in. So let's begin. So let's begin. Let's do one thing. Let's do a private static int is even. Int number that should be a bool. In mod 2 equals 0. There we go. And now I'm going to replace that with this, and we'll see why we do this in a minute. There we go. Alright, so there's the declarative way to do it. Let's look at another way to do it, though. That's the imperative way. I just said declarative. That's the imperative way to do it. Now let's look at another way, and you can already see it's already found what we want. So let's talk about this line. So evens equals numbers. So numbers where is even. So what we're doing, should be so where the number is even. So what we could do here is we can say n equals n mod 2 equals 0. So that'll do the exact same thing as we had before. And we add it to a to list. Here, let's do this. Let's make this a var. Now we don't have to do that, so we can just say this. Now we can drop this to list for the moment. So now we can do this. So now it's an even. And it's giving us an IEnumerable instead of list. That's why I changed it to var. And the string join here takes an IEnumerable, so that should still work, and we should get the evens. This time, though, we didn't tell it to loop through this. We didn't tell it to check if it's even, and we didn't tell it to add the numbers. All that was handled with the where clause, the where method here. So we're saying get the numbers where this condition is met. It's called a predicate. So this is our predicate. So we just added a method down here that does the exact same thing. So let's just say is even, and then we'll pass in the end there, and that'll do the exact same thing. And it does. We can do a little cleaner though. You notice it grayed this out. If we control dot, we get the option to remove unnecessary lambda expression. So this is going to let us use what this syntax here. This is let us use this is even. That's called using the method group. So we're saying use this method where this condition is met. And it's just applying that to the predicate. So we meet that criteria. We pass in an integer and we return a boolean, and that's what our method is. So that's using a method group, and I'm going to use that for a lot of the rest of this because I think it makes it clearer what we're doing. But yeah, so that gives us an I enumerable. So if we hit a breakpoint here, we'll see, as we've seen before, we don't actually have the value yet. And there, I just enumerated it. So expanding the results enumerates it. So until you click that, it actually doesn't know what's there. You can see the once I've clicked it, it does. So if we add that to list back, now if we hit that breakpoint again, now it already knows how many values are there. They are 5, and those are the values. So we'll talk about it more as we go. I don't know why that's telling me that it's currently in use. It's not. Yeah, I don't know why it's telling me that. So we'll talk about this more in depth in a minute, but what this is doing is it's called deferred execution. So when it's an I enumerable, it doesn't actually run the I enumerable until we hit something that does a string join. A for each loop will run it. We'll see some other ways to do it as well, but the to list forces the enumeration while where does not. So that's a more declarative way. So we're saying the exact same thing with these two blocks. Let's move on to so where here is filtering. So we're filtering out values. We can also do more operations. So filter, we can do something called a projection as well. So let's say we want to filter the even ones, and let's say we want to square the results. So we could do that here. This will work. Control U. We could do that here. Let's, instead of evens, let's do or even numbers. This needs to be a list of int. All right, and here we can remove our breakpoint. All right, so let's do this 2 ways. So here we're doing our is even, and then we'll do a select. So the select is the LINQ, is the LINQ way to do a projection. So a projection just says apply this to every value that we have. So let's just do a select n times n. So square every value. And we can do that here as well. We can just do times number. Now we should get the same thing again. 4, 16, 36, 64, and 100. Good. So we can filter out more here if we need to. And let's just say we need to undo this. Let's do we'll go back to the former syntax. And n is greater than 5. We'll set that. So now we need to add that. There we should get the same value. We did. that's doing a little more filtering. So now we're filtering, saying if it's even and it's greater than 5, then select. So then for each value there, or square it. So project n squared to the value. Here we're doing the exact same thing. So here, this is starting to get a little unreadable. So what I would suggest here is to do this. And there. Now it's a little more readable, and that's the way you're going to see it most of the time. Maybe not all the time, but usually if I've seen LINQ, it's on a separate line like this, and I think that's pretty common. But yeah, so using the select there, we're able to project something. So I think the concept in data science is we're changing the shape of the data, not the count. Where's filtering data, so we're changing the count. Select's changing the shape, so we're adjusting the data. But sometimes you want to sort stuff as well, and LINQ provides a way to do that as well. It gets a lot harder here for the even numbers. Let's just say we want to flip them. Let's do even numbers dot reverse. There, that will do it. So if we wanted to create our own, we could do that, but we would have to do that adjustment. Here we can just do select, and then we can do order by descending. And we'll just say n. Now we should flip the values there, and we do. There, I picked order by descending. There's also just dot order by, and that's the other way. So descending and ascending. So there, we've made the equivalence here. So this line here is equivalent to these lines. Now, I would argue that this one's perfectly readable. I probably would actually consider splitting out this condition because it could get bigger, but it's not that big yet. And same thing here. But as of right now, these are the same, and this one's more compact. And I would argue this one's a little more readable and readable if you go back to it and about it. If it's not, it's because it's new and something we haven't done before. But if you've seen this a couple times, I think you'll find that this one ends up being easier to read in the long run. One other thing here, say it's easier to read. I don't necessarily think it's easier to write. A lot of times I will think of this implementation first, and then think of to add something like that. And look, it doesn't even do the same one I picked. So all these. Yeah, it's not even going to give me the option because of the reverse. But as you've seen there, it picked a different value there. It's adding the numbers with a range. That is not what I chose to do here. Oh, there might be what I chose to do. Yeah, where a number is even. Yeah. Okay, so yeah, so that does the that did it just did an add range instead of a. Oh, there. It's doing it to a different value than I'm doing it. It's part of the problem. So there, it did pick the same things, just slightly, ever so slightly different. Oh, that's because I'm ordering here. But yeah, so it did pick the same thing, just slightly differently than I would have picked it. But yeah, so LINQ does it, and your IDE will have ways to do what I just did. So control dot. Well, that's just giving you the way to convert. And a lot of times, if it's something I'm just coding, a lot of times I'll end up with the for each method, and then when I go back through and clean up, a lot of times I'll run into the switching it to LINQ, and a lot of times the LINQ's clearer, and it's just that's not the way I learned it when I began. Um, but yeah, if you if you're thinking of LINQ, if you're thinking of doing something with data, a lot of times LINQ's going to be the clearer thing to do. So there we've looked at filtering, projecting, and sorting. Let's do another example of sorting. And this is why I've got the other code down there. So we have a person here. And the person's just a class with a name and an age. So let's make some, we'll make some list of person. We'll call it people, and we will do, that looks fine. So let's do this. Let's do for the numbers it generated, let's say if it's under 30, we'll do a var young people. Young people names. There we go. That's actually what it's picked here is actually what I'm going to do. So here we say where. So we filter the people. We say where age is less than 30. So just these two, Bob and Diana. Then we order by the name. So then Bob's still first. So the order by doesn't really change anything. And then we select the name. So this gives us an I enumerable of person. This gives us an I ordered enumerable of person. And then this gives us a string of people. And here we can just do that. There we'll get the young persons. We did. Let's do it the other way. Let's add one more too. Let's add a second Ethan. And we'll say this one's well, we need it to be younger just for this example, so we'll say 31. Now we've got two Ethans in our list. So our older people names equal to people dot where. That's probably this. We want to order by name. And then here's another thing. Then by age. There, that'll get us into the other order. So this Ethan will be before this Ethan. And here, if we do our console.writeLine, and now if we run that, now we'll get the other order we expect. Let's make sure that we agree, but we get Alice, Charlie, and Ethan. We can't tell which one's which, but it's the other one. Let's fix that though. We'll just make that. Now it's returning the person, and now we'll use our toString, and there you see the Ethan's correct. So there's just a little more order by, so you can use order by to say order by this property, and we can change that. We can do something else there if we need to. And then by a second property or second condition, and I think you can do more. I think you can do another then by, yeah. So if you add more conditions, you can add more conditions onto it. So there's a little bit of sorting, so you can use it to sort lists, enumerables, or sequences. A lot of times with this thing, you'll hear sequence. Sequence in this case is your sequence by this case is your sequence of values, so your I enumerable. So there's that. Look at another topic, aggregation. Let's grab number again. Let's do control. Let's free that one. Let's do do some numbers here. We'll do console.writeLine numbers.count. So count doesn't. We know we already have a count property instead of IEnumerable count. If we look here at this, here, we get the count LINQ method was used on a type that supports an equivalent, more efficient length or count property. The method's already a little more performant, but a lot of times with the count method, it's actually counting the values. I think count for lists is actually smarter than that, but if this was an IEnumerable, it definitely wouldn't be. So here, let's add our evens here. And we'll remove the order by. So now we're making everything bigger. Now if we switch this to evens, now it doesn't give that option because IEnumerable doesn't have a count property. So when it does the count, it actually has to go through each value and check. So there we should get a count of 3. And we do. Another nice property is console.writeLine evens.sum. So this is doing the adding up for us. So we could add up the results ourselves. We'll leave that. So if we wanted to do it ourselves, we could do something like for each var sum equals 0, sum plus equals number, sum. And we should see the same value here. 200, 200. And that makes sense because our values were 36 and then 64, which is 100 and then 100. So 200 makes sense. So that's it. These two lines, this line is equivalent to this line. These lines. So there's a sum. So sum, you can do adjustments here. You can pass in a value here and you can do some kind of x plus 1. Now we should get 100, 203, I guess. 203, yes. I don't think I've ever actually had to adjust the sum before. By default, it does what I expect. Where it wouldn't be was if we were summing the people again, and we wanted to take just the ages maybe. So if we do something like this. Now that doesn't make sense because it does not contain a definition. And it can't tell what type it is. So we can do this for each person, x.age. Now it can understand that one. So you can do something like that and add up the ages if you needed to, or add up some kind of property. So that's how you can use that. I generally don't think I've ever actually needed that, but this is the perfect some case like this where you have a object and you need to add some value in it. You can do something like this. Count, on the other hand, I have done count before. Here we're doing evens. Let's say if we had the original numbers. I have occasionally seen something like this. Is even because we have that method. So use that method group again. So here we should get a count of 5, right? And we do 5. So I have seen something like that before, but I haven't used the sum really. Another one we have is console.writeLine, or there's an average. I actually don't think I knew that one. So let's just look at the average of the numbers. So yeah, so we can take an average apparently. 5.5. Yeah, I think that's right. 10, 20, 30, 40, 55, and 55 divided by 2, or divided by 10. So yeah. Okay, so we have an average, so there's just a bonus. That wasn't where I was going. I was going for any. Now we need some kind of condition. So this is just saying if there's any values in the numbers, and we say true. You can also do something like this. We can pass in is even. So now we're saying is any value in there even, and it'll be true. So that taking in, if you don't have a value, it's saying is there any value in this collection? If you pass in a predicate, it says is there any value in this collection where this condition is met. And occasionally you'll see that. A lot of times you're better off doing the where and doing your own filtering and stuff and then passing it in numbers, but sometimes you'll want to do something like this, and I've seen that used a lot. I've seen this one used less often. Oh, and you see it wasn't valid there without a value. So here we're saying where all the values are even, and this should be false because they're not all even. We pass in the evens instead. Now we should see this run true. I haven't seen that one as much, but I have seen that any of some. Let's see, is there another one? Let's see. Dot none. Oh well. There's a max and a min. So I bet max, let's do it. So evens max should be 100, right? 100. Min should have been 36. There's two more methods to go with the average. Yeah. Those are pretty self-explanatory. Count. We'll look at a lot of these next time. First and last. First. And we know first is going to be 36 because they're in the default order. Last will be 100. Or you occasionally use them for this and that, and they're doing exactly what you think. They're taking the first or last element of a list. So if it was an actual list, if we did a dot to list, now we can do last, but more performant, we can just do what we did before. There's the first value, and we can use the index like we did last time, and there's the last value, and that one's actually more efficient than using the first or last. But if it's on an IEnumerable, we can't index into it. It doesn't necessarily have an indexer. And I'll apply indexing with that to IEnumerable. And that's where you'll use first and last. Let's see, anything else? So yeah, there's a lot of different methods here, and we'll look at those in upcoming lessons. But I think that's all we're gonna hit on these for the moment. Yeah, I think that's all I'm gonna cover of these at the moment. We'll keep moving. Yeah. Okay. So all though is one of the options as well. All is even. All right. Let's move on. I'm making better progress this time. So let's look at the idea of deferred execution again. We'll do this at the bottom. Let's do var numbers equals this. It should be list of int numbers equals, let's say new numbers so we don't mix up with the previous ones. So now we'll say var query equals numbers dot where, we'll just say is even. So the numbers where it's even. So now if we do a CW, we'll just do string.join query. So here we should be expecting to get nothing. And we get nothing. Good. So now let's add something to the list. We'll say 1, 3, 5. Now we should get nothing. And we get nothing. Now let's do this. Let's do query. Let's do new numbers. My value. New numbers dot add 4. And now let's query it again. Notice what's happening there. Even though we set query up here when there was no even numbers, we added a number down here and we got the query out. So what's happening there is it's called deferred execution. So we're actually storing the query in this case rather than the actual result. We did a dot to list. Now if we look at this, we will see it's empty both times. That forces the evaluation. With it like this though, it's deferred, so it says whenever this runs, see what the value of new numbers is where this condition is met. And we do that here in this string joins. The other time you do this is in a for each loop. Anytime you do a for each, it's running over the query, it makes it real. Some of these other operations we just did a minute ago, they do that as well. They check what's actually in the IEnumerable, so in the sequence. So it doesn't. None of that happens though until it's enumerated, and that's what when we get that pop up in the debugger that it says the expanding this will force the enumeration. That's what's happening. It's forcing the enumeration. Until that point, that actually hasn't run, so it doesn't know what the number actually is. But yeah, so there we've added a value, and even though we set it here, it's not actually run until later. So that's deferred execution. One more thing is there's another syntax for this. So let's move the final topic. Come back to this. Yeah, we'll come back to this. So here, let's move this down. So here we have this again. We agreed that this is. Oops. We agreed this is doing the same thing. I lost even numbers. So we're doing the same thing here and here. Use these as well. So there's another syntax for this. So this works, but we can do another way to do this. So here's the other syntax. So we can do var evens equals, and we'll do this on a new line, from in numbers where, yeah, that, it's like 10 times in. Now this will give us the exact same values. It's just a different syntax. Oh, and I guess we need to sort it. Not do that. And there we go. Okay. So this is a different syntax. So this one and this one are doing the same thing. Put that up here. So those are doing the same thing. So how you read this is you say from the number in numbers, so each number, where it's even and greater than 5, order them by descending, and then select n times n, so project it onto that. This syntax might be more familiar if you've done a lot of SQL, so if you've done a lot of databases. So in general, I find this one to be the more common in C Sharp. This is the one I would use personally, but I haven't done a lot of databases. I haven't really done databases since I was in college, so that's one of them experience things. But for the most part, I think you'll see this format over this format. But they're doing all three of these are doing the same thing. It's just different ways of expressing the same thing. Yeah. I guess one thing is that this one, when you're compiling C Sharp, it goes through different steps. One of the earlier steps is this will get actually converted to this one, I believe. So this one's lower level than this, but I would still argue that this one's the more. This one's the one you're going to see more frequently, I would think. Maybe not 100%, but that would be my expectation. And this one makes more sense to me. You filter, and you adjust the filtering, and then you sort. In fact, this one's wrong, isn't it? Yeah, wait a minute. Maybe not. Yeah, I'm not sure if that's giving me the same answer, actually. I'm trying to think how I would adjust that so that it wouldn't be the same, but I'm thinking through that. I'm not sure this is actually giving me the same value. What we might want to do here is just take this and then sort or reverse the evens at the end. So yeah, I'm not even 100% sure this is correct. Yeah, I'll. I'm not sure on that. I'll try to think of a way to actually check that for next time. But let's finish up real quick. So yeah, so there's different formats. Pick which one your team's using, and that's probably the correct way to go. I would suspect it's going to be this one, but if you're doing a lot of databases, it may be this. Maybe you're more experienced with this format, and maybe that's where you'd gravitate toward. Let's see. Last little bit we're going to cover. Sometimes I'm running LINQ or rerunning LINQ, like up here when I was doing my query. If the query here was big, like say instead of just 3 numbers here, instead we had a billion numbers in the list, then that where might be pretty slow, and rerunning it twice here multiple times, you could run into a lot of performance issues that way. So one thing to keep in mind is when you're running through LINQ, it's doing a lot of looping that you may not need to do. So that's one thing to keep in mind. Another thing, I've seen large ones there. Let's comment this out. Undo this. So here we've got what three clauses here, three expressions. I've seen much larger. I've seen some 12, 13, 14 of these. At that point, a lot of times you're going to be better off breaking that up in a smaller part. That's you're going past the being a little more readable to being unreadable again. So occasionally you can split it up into smaller pieces, and that'll be more readable than having it in larger. Sometimes larger is fine. Like I would be perfectly fine with having it 3 here rather than breaking this up into 3 separate pieces. But think about how you like it, how it makes sense, and split it up however you would like. Um, I will mention for toList. So when we do a toList, as we've seen here with this bottom example again, it freezes whatever we have. So you can think of it, it takes a snapshot of the current value, and that's as far as it goes. Running the query later will get you the same snapshot. If you don't have a toList, toArray, or whatever, it'll rerun the query again. So keep that in mind. That could occasionally not be what you want. Could be what you want. It depends on your situation. Um, that's pretty much it. I guess one other thing, I generally see toList rather than toArray. I think a lot of that's most people prefer to work with a list instead of an array because the list can be expanded. So usually you'll see a list of. I also believe in the past, I haven't tested this. I don't know this for sure. But I believe that I heard toList is more performant than toArray. I don't know that for sure though, so I'm not going to say that for certain. But one thing to keep in mind, maybe test at some point, and you can see if your situation, if you're really needing performance, maybe think about that. All right. Yeah, I think that's all I wanted to cover. I'm about a little short on time, but not too much. So let's just finish up. So LINQ, it's a way to make data working with data more expressive, more concise, more direct. Instead of doing imperative, telling the computer every step we want to do, we instead tell it what we want, and then we let it do the steps. So a declarative programming style rather than an imperative programming style. Your goals to be a little more readable. I personally think this is more readable than this line's more readable than these lines, but not everyone agrees. More experience you have with LINQ, I think it gets easier. So you've done a lot of LINQ, maybe it's easier to read than if you haven't. Um, Another thing, LINQ expressions are a lot of times are deferred, so they don't actually run until you actually need them. And yeah, they or you can use it to build up more powerful things. And as we've seen, just skimming through the list of that what's available, there's a lot of options and a lot of things we'll be looking at too in future lessons. So in the next lesson, we'll probably be looking in. I say probably we'll be looking into more of the LINQ functionality. So we'll keep building up there and move into a little more of the. I want to say advanced, but a little more of more the features that are a little harder to grasp, I guess. Most everything here, where we're filtering, select, we're projecting, and order, we're sorting. So, not too hard. And I would say projection there's the hardest, and all you're doing there is just you're saying apply this to every value, but maybe filtering out a list, maybe that doesn't make sense to some people, but I would say that all three of these aren't all that complicated, and I would say that I would say it won't take you long to grasp when to use them and how. And in C sharp, modern C sharp, you tend to see these quite a bit. If you've ever done any programming problem solving, a lot of times you'll things like LeetCode or other challenges like that, you'll see C sharp, and you'll see if you see C sharp, it'll be something like this. So one thing to keep in mind. So we'll call it there. So next time we'll keep going with LINQ. So we'll stop here. So thanks for watching and have a wonderful rest of your day.